let's get this show on the road. You couldn't see that from the camera, gosh. Dang. Alright, ladies and gentlemen, let's get this show on the road. So, you want to learn about linked list? Well, either you're a nerd or you're my teacher, and you're forced to grade this. Either way, I'm gonna have to tell you about it, so let's go. A regular old linked list is a data structure that uses nodes to connect data points. As you can see here, you've got individual nodes like node A, node B, and node C that each hold their own data, and they point to the next node. Note that node C actually has a null pointer at the end, and what that means is a whole bunch of nerd stuff. Then you've got the natural evolution of linked list. What is it called? Then you have the natural evolution of a linked list with a tail. Basically, an external node that points to the last piece of data in a data set. Finally, you have doubly linked list, and this is the type that probably most data structures use, where you've got node A, node B, and node C, but notice that node A is pointing to node B, while node B is pointing back to node A. In that way, you know which node is where in relation to each other bidirectionally. So how do you interface with one of these fancy linked lists? Well, let me tell you, you do it with the add method. You should have known that if you're watching this video, but I'm just going to tell you. The add method, get this, it adds things to the list. Adding things to a linked list isn't necessarily that difficult. You start here, where you have a section that parses through each data point until you get to the index of the position you want. Then you have a line here that instantiates a new list node as it is assigning it as the next piece of the node list. Going back to our diagrams, you see list node A, list node B, and list node C. Let's say I want to add a list node D to this mix. So what I do is, remember that code back there that parses through everything? Goes list node A, list node B, and then it says, hey, list node B, instead of having list node C be your next object in the list, you have list node D, or whatever I just said, as your next object. And while it's doing that, it's also making that object. There are a couple of exceptions that you have to hard code in, namely, your head is null. You're adding to the last index of the list. You're adding to the first index of list, and head is not null. Now, there is a little bit of a difference between the regular linked list and the linked lists with heads and tails, as we saw earlier with the diagrams. So whatever I just said, kick it out the window. Just kidding, don't do that. It's practically the same thing. Basically, all it is that for tail, you have to actually, say where the tail is. And for doubly linked list, you just have to make sure that you tell the list node object that the one before it was the one before it. Moving on, however, you might also want to take away things from the linked list. You'll never be able to guess what subtract does. Go on, guess. It takes away objects. So as you can see here, we've got another parsing section so you can get to the referenced object. And then basically what you do here is you tell the object at the index before the object you want to subtract that object that was in front of it never existed. You got that? You got that okay? You got that all right? Do I make myself clear? And after you scare it into forgetting that object is gone. And so yeah, that pretty much wraps everything up. What do you want me to say? I'm done. I'm done. That was one take, baby.